Hi, my name is Jean-Jacques Debray, and I'm the author of a new pattern called the SAM pattern, and I'd like to give you a quick introduction. I work for XGenio. I'm the founder of it's a small consulting company providing architecture services, building platform and tools, and delivering web, mobile, IoT, and chatbot solution. These days, our favorite stack is angular2, Node.js, AWS Lambda, and AWS. We base our work on a new blueprint that's using the SAM pattern, and I'll talk a little bit about it at the end of the presentation. And we have a variety of customers, large companies, and startups as well. So why the SAM pattern? Today, the user experience require that front-end architecture are capable of dealing with network events in the same way that they've been dealing with user events. You look at Facebook or Twitter, or pretty much any application these days, and users expect that the front end will react to events coming from friends, players, your watch, IoT sensors, etc. You can no longer assume that the user will be the only source of events in the application. So if we take a quick look at the way people have been writing code to build front ends, that code has not changed much in decades. Pretty much since the Mac was invented in 1984, the primary model was very similar, and then with Windows 3.1 and Windows 95 afterwards. So if you take the example of drawing a rectangle by dragging a mouse, the code most likely would look like a bunch of events and event handlers. And the problem with that kind of code is that it's hard to compose. The events are just functions, and the relationship between them is pretty much at the discretion of the developer. They offer poor encapsulation. The model is often based on global variables that can be changed at any point in time in the handler. It's also requiring that you manage subscription effectively because a mouse down event might mean something in one context and another in another context. So there's also poor separation of concern where the DOM manipulation is generally right there within the handler itself. And these days you see appearing a new problem, data consistency. So even though JavaScript is single-threaded, because single-page application generally call APIs, you start seeing the same phenomenon you would have in a multi-threaded application where a part of the code starts modifying the data model when another one comes in and start modifying the other part of the model as the I/O interrupts the different quote threads, and you start to worry about data consistency. Last but not least, this code is brittle, it's hard to maintain, it's hard to hand off when a developer leaves the team and new ones need to be onboarded. So after some intense research, the industry has come up with a solution, and that solution was, in the case of angular1 or even React, is, well, to put an object wrapper around the code. In all fairness, they also more cleanly separated the view from the handlers. For instance, in React, they introduced functional HTML, where when you change the application state, the component state, it will automatically re-render so that you don't have to worry about it. However, that model didn't work. Nowadays in React, people advise to use stateless component as much as possible, and Angular2 has somewhat, evolved to at least not force you to use that model. So the reason why this doesn't work is because it creates a really strong coupling between the view components and the application state, the model. And when the view needs to change part of the application state, and then the components need to render, you start having lots of back and forth between your view components. So that's the main reason why you want much better decoupling between the view and the model. And one of the reasons is because that code tends to be extremely buggy. In 2007, Sean Parent did some study at Adobe and figured out that the handler code was about 33% of the total code base, but about 50% of the bugs were reported in that part of the code. So most recently, in the last year, 2 year, people have started to adopt a functional reactive programming model. You can see that with Elm or Redux. And basically what you have is when an event is produced, you enter a function, and because it's a pure function, it's on the assumption that the model is in essence immutable. So you make a full copy of the model before you start modifying it. Once you mutate the model, then you replace the old copy with the new one. And once you complete the mutation, you trigger the rendering mechanism with the view, and the new property values are rendered. So that is better than kind of full-fledged components, but this is, I think, suboptimal. This big red box is a big function, and the SAM pattern argues that there's a better factoring for this code rather than just let it at the discretion of the developer. So let's introduce the SAM pattern. SAM stands for State Action Model. SAM targets the same problem that we're all trying to solve, which is how do we process events from the view into updates to the model, and once those updates have completed, how do we render the view? So from the model to the view, the SAM pattern, is open. It's not necessarily a constraint, but it works really well when you adopt a functional HTML approach that was pioneered by React. That model, if you're not aware of it, if you never used it, I would definitely recommend taking a look at it. This is a game changer because it completely isolates the view from the need to know anything about the business logic, even the model itself, because in essence what you do is you translate the model into properties that are consumable by each view components. Where SAM differs is on the other side, where an event occurs. If we take the simplest application, let's say we want to count some user events, most developers would write the code as such. They would write counter equal counter plus 1. And that's what SAM is challenges. And this is, by the way, the code that was in the red box in the Elm or Redux example, everyone using that code. What SAM is saying is that you cannot, in other words, if you use an assignment, counter equal counter plus 1, as an approximation to state mutation, you're doing something wrong. I discovered that when I started to look at the work from Dr. Lamport, a researcher at Microsoft. That work is TLA+. He got a Turing Award for it. It's very important work. I recommend anyone to become familiar with it, and it's very inspiring. It's literally changing the way you code. So if we go back to what it means to application state mutation, what TLA Plus suggests is that you should start by creating a proposal. And the proposed value would be counter plus 1. But you still couldn't make an assignment with that value. That wouldn't make any difference. But the way you should do it is you should ask the counter, the model, to accept the proposal. And then, only then, once the application state has mutated, then other aspect of your program can access the model and do something with it. Neither the proposers nor the learners can modify the model. There is no assignments, there's no random assignments in SAM. All the application state mutation happens in the model. And this mutation happens with a proposal that can be accepted or rejected. So if we look at it on a picture, the proposers are the actions, the acceptor or acceptors are the model, and then what we have is a state function which create a state representation, namely the properties. They're more complex mechanism, but at a high level you can look at it as translating the application state into a set of properties that can be consumed by the view. Another important aspect of the state function is actually to compute if there is a next action to execute. In a given state, you might have an automatic action that needs to happen once you reach that state, and the state function will trigger that action, which will propose a new set of values to the model, which will accept or reject them, and trigger the state function, which will render the state representation in the view. Now, if you look at this red box, the functional aspect of the ELM or the Redux programming model, what you see is the SAM pattern, the actions, model, and state are three different buckets that you can use to implement the code that you would otherwise put in the reducer or in the update function of ELM. And I believe that's a better factoring, a much better factoring. So if we create a different representation and we look at model view controller, React and Redux, and SAM, we see that there is a subtle difference between SAM and Redux. It's not, a lot of people come back and say, oh, it's kind of the same, or I don't care, I've heard that several times. But in reality, it's not. In other words, mutation is not something that you can make up. Dr. Lamport created a very precise model to mutate the application state, and that model is not something you can tamper with. So again, I would recommend that if you use React, Redux, or angular2 or any other framework, you take a look at the SAM pattern, because you should see some value in using it. Now, let's look at some code. I picked up this very nice template from this company called Acveo. They created an admin template. It's very, very great, great work. And what I've done is I modified that template to implement the SAM pattern. All the code is available on the SAM pattern GitHub repository, and there's a link at the end of the presentation for that. So let's look at how Acveo implements components, and that's pretty much by the book. This is the kind of code that you see everywhere in the angular2 literature. And what you see here is basically the component is self-contained. It has the view, of course, which is the template, and it has the model, say the to-do list here and the new to-do text, and it has the business logic. When you add a to-do and so forth, it would implement the business logic right there. That is wrong. I really want to emphasize that that is wrong. This is not how you should implement your application. So how do you implement it with SAM? So first, it's important to be very clear with events and properties. So in angular2 you have templates, in React you have JSX, in other frameworks you have some different mechanism. At the end of the day, it's all about events and properties. The view component emits events, and it expects that new properties will be provided so that it can render different content. So if you look at the same component implemented with the SAM pattern, what you see is first, all the implementation of the action, check to do, add to do item, delete, etc., is gone. It's basically wired to an action call in SAM. And then all you have to do is you have to subscribe to updates to the properties, and that usually happens in the constructor. And that's it. All implementation of Angular 2 components using SAM will look exactly like that. Nothing else, nothing more. From there, you can wire the SAM code, the actions, the model, and the state. Bonus points, you can also wire server-side actions or third-party actions that have nothing to do with the view components themselves. And because of the SAM architecture, any changes to the model will be reflected in the view components through the subscription of those components. So, and I've shown it. I've shown that when Angular 2, when Google decided to completely change the programming model 1 month before the final release of Angular 2, I was able to reuse the SAM code 100%. All I had to do is download the new template, change, of course, the implementation of those methods, but they're similar to the one I had implemented before. There was just slight variations on the module declaration, and I was ready to go. And by the way, you could even change web frameworks altogether. If you wanted to switch from Angular 2 to React, it will be doable. If you use an implementation model with kind of self-contained view components that have business logic, state, and templates, you basically will never do that. And if you build a large application with Angular 1 or Angular 1.5, you know exactly what I mean. So how does the SAM code look like? It's really easy. An action translate an event into a proposal. So it will simply create a JSON structure, a payload that will be presented to the model. What you see here is the business logic that used to be in the component is now centralized in the model, which itself could be factored in individual units of work. And then once the model has mutated, then it will ask the state function to render the model. In this case, we just select the to-do part of the model and we publish it to the topic, the dashboard to-do list topic, which will be received by the view component, which will react to it and render that view. I want to emphasize that even though Angular 2 supports two-way data binding, you should never use two-way data binding. It's okay to use one-way data binding from the properties to the view. You should never have the view directly modify the content of the model, the property values of the model. That is an anti-pattern. You should never do that. So another aspect that I wanted to talk about with the SAM pattern is how it plays in the application, the overall application architecture. And you have the services, APIs, microservices. What we suggest is to use API calls both in the model and the actions. In general, you would put queries in the actions, and any updates, create, update, delete in the model. The reason being, it's hard to represent the state if the side effects have not completed. All the create, update, delete calls need to complete in order to render the correct application state. So, but this is open to interpretation. You could also put them in the actions. Now, if you look at the overall architecture, one of the beauty of SAM is that because it's a pattern, all the code that you write, actions, model, etc., is framework free. It's just pure JavaScript, and which can be ES6 or ES5. It doesn't matter. It could be any language, for that matter. But what's important is that we've shown over and over in all the examples that we've produced is that the code that we write is 100% isomorphic. What it means is you can take the decision at any time, even after you ship the first release in production, you can take the decision to move actions from the browser to the server. And they nicely map to the API layer, the model maps to the service layer, and then you would have your microservices as the integration point to the system of records. So SAM is very friendly to a service-based application architecture. The code is isomorphic, and I've even shown that the code can run unchanged in AWS Lambda as well. So that aspect is, I would say, unprecedented. This is something you'll never be able to do with Elm or with Redux, for that matter. In the enterprise, GraphQL is not a good solution, and what you would want is probably to use something like SAM with proper API and service layer to integrate with your system of records. So in summary, the programming model of the pattern is centered on mutation, not immutability. It is based on a single state tree, a true one, not like Redux, for instance, which requires sagas in some cases, which breaks the single state tree paradigm. It's also focused on what's allowed. There's no subscription in SAM. And I've built a library called SAFE, the State Action Fabric, that illustrate how you can very effectively manage the allowed action versus event subscriptions. The big benefit of SAM is that the view components are 100% decoupled from the application business logic. You can see that in angular2, you can see that in pretty much any other framework. And SAM really likes functional HTML, but as we've seen in angular2, using a template mechanism is not a deal breaker. However, it can only be used in a one-way data binding, not a two-way data binding. From an architecture perspective, the SAM pattern can be implemented with the framework of your choice. I tend to like angular2. It was an unlikely choice when I looked at it first. I felt, this is just too complicated, and it's why use angular2? But after working with it in TypeScript, I must admit that I like it. SAM is side effect friendly. You don't have to sweat over making API calls. You don't have to use ancillary state machine and declarative effects. All this goes away. It's completely pointless. In particular, SAM is wiring agnostic. You don't have to use RxJS. Again, this is completely superfluous. Wiring brings no value. The primary model brings value. Architecture brings value. The wiring brings no value. SAM is truly isomorphic. You can move your code from browser to server and back to browser as much as you want. It allows you to implement very interesting mechanisms such as action hangback or generic cancellation. And you can also weave in your programming model third-party actions, say using OAuth tokens, for instance. If you have any questions, please join us on Gitter. You can find all the links at sam.js.org, and there's my email address here. If you have any question, feedback, we're always happy when people use the pattern, and there is a growing community at this point. Thank you.